Okay, in this video we're going to look at just reviewing what some of the exponent laws are, and then we're going to look at a couple new exponent laws. Okay, so the first laws that you would have seen back in grade 9 and some maybe in 10 are the ones here on this side. So basically the definition of an exponent, x to the n, means x times x times x. Keep going, and you do that n times. So for example, 2 to the 3 is 2 times 2 times 2, which is 8. Okay, and then if you are multiplying powers with the same base, so x is the same base here, then you can add the exponents. But if that was x to the a times y to the b, you couldn't do anything. Okay, so because you have the same base, the base is the x, the exponents are up here. Okay, the whole thing together is called a power. When you're dividing, you're subtracting. Okay, so when you're dividing with the same base, you subtract the exponents, top minus the bottom. If you have a power of a power, so x to the a to the b, you just multiply them. And for x to the negative a, that's equivalent to 1 over x to the a. And then x to the 0 just equals 1. And all these have been proven in previous videos, so you can look in the grade 9 toolkit for exponent laws, and they've all been shown in there. And then we have some others over here, so I think these have been shown as well. So xy to the a, you can distribute that exponent in to a product. Okay, so x times y to the a is x to the a times y to the a. And this one here, same for division. You can distribute it into a division. So x over y to the a equals x to the a over y to the a. And then 9 and 10, these are new. So these have not been shown in any of my videos. So x to the 1 over a equals the eighth root of x. So we're going to look at exponent rule 9. So number 9. And we're going to look at why this is. Okay, so if you took the square root of x squared, that would equal x. Okay, we know that. If you took the cube root of x cubed, then that should equal x. Okay, so the cube root undoes cubing, the square root undoes squaring. And so basically, if you took the nth root of x to the n, that would equal x. Now, just using exponent laws, if you had x squared and then you did to the exponent 1/2, okay, so what we have here is exponent law 4, so a power of a power, x squared to the 1/2 equals x to the 2 times 1/2, which equals x to the 1, which is x. Okay. If you took x cubed to the 1/3, well, you multiply those exponents, you get 1, and you get x again. If you took x to the n, to the exponent 1 over n, well, if you multiply those, n over n is 1, and you get x again. So by doing the nth root of x to the n, you get x, or by putting x to the n to the exponent 1 over n, you get x. So it has the same effect of, so this 1 over n exponent or nth root. So from this, we can conclude that x to the 1 over a equals the eighth root of x. Okay, so those are the same, and that's exponent law 9. Okay, so this one here. Now we're going to look at 10. Okay, so 10 is just really an application of that. Well, if you have a rational exponent of, say, x to the a over b, well, you can divide that fraction up. You can say that that's x to the a to the 1 over b. Okay, so a times 1 over b is a over b. So we're just breaking up this fraction into a multiplication. Okay. And that's the same, because it's a 1 over b, that's the same as saying the bth root of x to the a. Right? Another way of saying this is we could say that this is x to the 1 over b all to the a. So we can break up that multiplication like that. Instead of like this, it's like this. And then that would equal the bth root of x all to the exponent a. So x to the a over b equals the bth root of x to the a, or the bth root of x all to the a. And these are the reasons. Okay, and that's those two laws there. Now, two that we want to look at here. So we mentioned that in 7 and 8, you can distribute the exponent in to a product or a quotient, division. What you can't do is you cannot distribute an exponent into a sum or difference. So plus or minus in those. Okay, so you cannot distribute the exponent into a sum or difference. And we know this from, if you think about x plus y squared, if you did that, you'd write x plus y times x plus y, and then you'd FOIL it out using the distributive law for expanding a binomial times a binomial, and you would have x squared plus y squared, but you'd have this middle term in there as well. So you try that and you'd see that it doesn't work for 2, it definitely doesn't work for 3. And the same thing applies here for a root, because this exponent a could have been a rational root, and that's basically what's happening here. So you cannot distribute a root into a sum or a difference as well. Okay? And that's it for exponent laws, the new ones. So we could do an example of this by maybe simplifying. So let's try and simplify. Okay, so if you want to simplify something like this, well, first thing we're going to do is try and get rid of these brackets and simplify the top and then simplify the bottom. So this exponent distributes into both these pieces. So the 3 is going to go to here, so 3 to the 3, and then x to the negative 2 to the 3. Okay, and then we've got times 4 x squared y cubed, and then down below we've got still the 9 and the 12, so we can leave those there for now. We'll simplify them soon. Okay, so 9x to the negative 5 times 12, and this squared is going to be distributed in, so x squared squared, well, that's going to be x to the 4th, and then y to the negative 2 squared. Okay, so we wrote it out up here. Do it again here. Y to the negative 2 squared. And we simplify it one more time. So you can skip steps in this. This is a long way of doing it. Okay, so 3 cubed is 27. X to the negative 2 to the 3 would be x to the negative 6. Okay, times 4x squared y cubed over 9 x to the negative 5 times 12 x to the 4 and y to the negative 4. Okay, so now we could work with the numbers first, the coefficients here. 9 and 27, so 27 over 9 will reduce to, well, 3, right? So 27 divided by 9 is 3, so I can get rid of that, and just put a 3 there. And 12 and 4, well, that will reduce, so that 4 would go away, and 4 goes into 12 3 times, so change that to a 3. And then the 3 and the 3 here, they go away. So it gets rid of all the constants. Okay. Now, the x's, well, the x's on the top, you're going to add the power, so I'm going to write x to the negative 6 plus 2, and then I'm going to do minus negative 5, because x is on the bottom here, we're going to subtract, so minus negative 5, and then a 4, so minus 4. So that takes care of all the x's. Then we put the y in here, and we got a y to the 3 on the top, and a y to the negative 4 on the bottom, so minus negative 4. Okay, we simplify that, so negative 6 plus 2 is negative 4, and minus minus 5 is going to be plus 5. Okay, so negative 4 plus 5 is 1, and then minus 4 is going to be negative 3. So I got x to the negative 3, and then y to the 3 plus 4 is 7, so y to the 7. And then we're going to write this with positive exponents, so that's going to be y to the 7 over x to the 3. And that's what that whole thing simplifies to. Another example. How about this one? Fifth root of x squared times the fourth root of 16 square root of x cubed. Okay, something like that. Okay, so we're going to change this. So this is a fifth root of x squared, which is going to be x to the 2/5. Okay, this one is the fourth root of 16 times the fourth root of the square root. I'm putting the square in there. You don't have to put the square in. You know that that's going to be that of x cubed. Okay. Well, the fourth root of 16 is 2. So I'm going to put that in front. 2x to the 2/5. And then this one is going to be x cubed to the 1/2 to the 1/4. Okay. And so now we have 2x to the 2/5, and then x to the, well, 1/2 times 1/4 is going to be 1/8, so it's 3/8. And now you have to add those exponents. So that equals 2, and I can just do it off to the side here. 2/5 plus 3/8. Okay, so that's going to be 40 as a common denominator. Okay, so that's going to be 16 over 40 plus 15 over 40, which equals 31 over 40. So that's going to be 2x to the 31 over 40. And that's that.